Good morning to all. Today we can discuss about the high frequency analysis of a common emitter amplifier in the subject analog electronics. So, what is high frequency analysis of a common emitter amplifier? So, it involves the analysis or understanding how the circuit capacitance and the signal frequency affect the amplifier's voltage gain. So based on the input capacitance, so the reactance will be affecting the reactance of the capacitors in the circuit changes with the signal frequency which affects your output voltage. So we assume that you have the two capacitance CC and CE or short circuits and CL is an open circuit. So this is your normal CE amplifier. So here you have a CL, that is your load capacitance. CE and CC, that is the bypass. CE is the bypass capacitance and CC is the in coupling capacitor. Both are short circuits and CL is an open circuit. So the input capacitance of an amplifier reduces the circuit gain by 3 dB when the capacity impedances equals the resistance in parallel with the input. That is your R1, R2. So the Miller effect also included. So the Miller effect amplifies the input capacitance of a common emitter circuit. So the what is how in the high frequency equivalent circuit of a CE amplifier, you can see the equivalent circuit. So the input VI, then RS, then what is this RB, R1 parallel, R2, and based on the Miller capacitance effect, you have the R pi, C pi, C mu, GM V pi. That is your current R naught output resistance, RC collector resistance, RL. So this part R pi C pi, that part and G up to GM V pi is nothing but the effect of your Miller capacitance. Now, in this circuit, it is actually reduced with the Miller capacitance effect. This is the C mu into that is GMB pi. In this part, this Miller capacitance is between the Miller capacitance is introduced. So it is taken as CM in the next diagram. And what is this RL dash? RL dash is nothing but R not parallel, RC parallel, RL. Okay, so that is actually combined in the output side. And in the input side, you are not going to change anything. So this is the simplified diagram with the Miller capacitance effect in the high frequency analysis of CE amplifier. Because the internal capacitors C pi and the C mu cause the high frequency gain to roll off. So this actually will be present whenever you are drawing a high frequency equivalent circuit of a CE amplifier. Okay. So what is the formula for Miller capacitance? As you have studied in Miller capacitance, Cm is equal to C mu into 1 plus Gm RL dash. Whereas the output resistance is RL dash. As you have minimized in the diagram, R not parallel, RC parallel, RL. So you have studied as GM RL. Now we have taken it is RL dash because we have included the effect of this R not also. Okay. So now the upper 3 dB frequency can be determined by using the time constant technique. So 1 by 2 pi tau. That is your time constant. What is time constant? R into C. It is nothing but R equivalent into C equivalent. What is C equivalent? You have the effect of the internal capacitance C pi and C mu. That is your C equivalent. And what is R equivalent? That is R pi in the input side. R pi parallel RB parallel RS. That is in the input side. You have a R pi and R1 parallel R2. That is RB. Then the input resistance. Both all are combined together will give you a R equivalent. So what is your upper corner frequency? 1 by 2 pi. R equivalent is R pi parallel RB parallel RS and C equivalent is C pi plus C mu. Okay, so that is your upper corner frequency. Based on this, your graph will be with the feedback, that is your Miller capacitance effect. The midband voltage gain is AVM represented. It is a graph between the AB and F. The FH will be 1 by 2 pi C equal R equal. What is the output voltage? It is nothing but the current source is GMV pi into RL dash. So the input voltage is RB parallel R pi by RB parallel R pi plus RS. That is your voltage. It is applicable like a voltage division rule. Voltage input voltage will be voltage across the input side, that is RB parallel R pi. With this your parallel constant RB parallel R pi plus RS. From that you have calculated your output voltage V naught as GM into this V pi is RB parallel R pi by RB parallel R pi plus RS into VI RL dash. So the midband voltage gain is V naught by VI. So from this V naught by VI calculated, so GM RL dash into RB parallel R pi by RB parallel R pi plus. So this high frequency analysis, see your voltage gain, even you have included the capacitance effect, it is not reflected in our output voltage, but it is going to change your gain since the voltage gain of a common emitter amplifier drops off at low and high frequencies but is constant over the mid frequency range. You are getting a high frequency response. This internal capacitance effect is going to generally roll off your gain. So that can be analyzed by using this high frequency analysis response. Thank you.